Today I'm going to show you a way to get precise, hands-on control over motion and camera movement in AI-generated videos. No more hoping a text prompt guesses what you meant. With Time to Move or TTM, you literally cut, drag, and shape the motion yourself, and the model follows it exactly. TTM plugs into models like WAN 2.2, Cog Video X, and Stable Video Diffusion, and stronger models give you even cleaner, more accurate results. WAN especially nails the motion you draw almost frame for frame. Let me show you how it works. So first, we need to install the interface. For the interface to run properly, we have to install several Python packages. All the required packages are already listed in the repository's readme file, so you can simply copy those package names into your terminal and install them. Once everything is installed, you can run the Python command to start the interface, and you should see the interface window appear on your screen. Inside the interface, the first thing you'll do is choose a file that you want to work on. I'll use one as an example here. The first real step in the workflow is adding a polygon. To create the polygon, just left-click on the image to mark points. This polygon defines the object you want to move in the final video. After you finish outlining the polygon, click the Finish button. Once the polygon is completed, you can drag, move, or rotate the selected object. For example, I can drag this object over to a new position. When you are satisfied with the motion you've created, you click End Segment. This will create a keyframe for the movement you just defined. If you want to preview the movement, you can click Play Demo, and the interface will show you exactly how the newly added motion behaves. There are some important tips when working with multiple objects. If you need to add more than one polygon, meaning you want to move multiple objects, make sure to work on them one at a time. Finish the first polygon completely, click End Segment, and only then start drawing the second polygon. Once the first object's motion is finalized, you can begin defining the second one. For example, after I finish moving this first object and end the segment, I can draw another polygon on a different object and start moving that one as well. One thing you definitely don't want to do is draw multiple polygons before editing their motions. If you select several polygons at once and start dragging things around, the system doesn't know which object you're trying to modify. When this happens, you will notice dotted lines around the objects. These dotted lines mean the motions have not been finalized or attached to your motion signals. Movements that remain dotted will not be recognized by the AI model, so the object won't move correctly in the final video. The key idea is to handle polygons one by one, finalize a polygon, end the segment, and then begin the next. This method works with different models, such as WAN and Cog Video X. If you are using WAN, you should leave the total frames at 81 and the FPS at 16. If you are using Cog Video X, you should start with 49 frames and 8 FPS. If you accidentally use the WAN configuration for Cog Video X, you'll likely run into errors when you try to run the model, so choosing the correct values is important. After adjusting all the motions you want, you can preview them again using Play Demo. This preview is usually very close to the final motion that appears in your video, although the model may still enhance or refine the motion when generating the actual video output. Another key part of the workflow is the text prompt. This prompt is sent to your model as a text description. You can write anything you want, such as the stone is, or whatever scene description matches your desired output. This works the same way as any image-to-video or video-to-image-to-video model. You need an input image and you need a text prompt. After writing your prompt, click Save, choose a folder, and give your outputs a name. Once saved, you can open that folder and see all the generated inputs: the first frame, the motion signals, the mask, and the prompt. This folder is what you will use as the input for the model, whether you are running the pipeline through Comfy UI or through a Python command. Once you have your input folder ready, you can begin running inference to generate the final video. There are two common ways to do this. The first way is using Comfy UI and the second is using the Python command. For Comfy UI, I'm using WAN as the base model. The workflow is basically the same as a standard WAN 2.2 image-to-video setup, and most nodes behave exactly the same as usual. The biggest differences are in how the inputs are loaded. For example, the image node should be connected to the first frame from your input folder. The video node should use the motion signal video generated by the interface. And the mask node should use the mask video. All of this comes directly from the folder you saved in the interface. The text prompt you wrote earlier can be copied into the prompt field in Comfy UI. Once all of the inputs are connected and set up, you can simply run the graph. The quality of your final result depends heavily on both the motion signals you created in the interface and the start and end steps you chose for the model. If something looks strange or doesn't behave the way you expected in the output, it usually means that either the motion signals need some adjustment or the start and end steps need to be fine-tuned. The second way is running the pipeline through a Python command. Before doing this, make sure all required dependencies are installed. If you want to use WAN through Python, you can follow the WAN 2.2 repository instructions. Since I'm showing CogVideoX as an example here, I install the requirements from the CogVideoX repository. Once everything is installed, you run the command that takes your input folder and your output folder. The input path points to the folder you generated from the interface, containing the first frame, motion signals, mask, and text prompt. The output path can be any folder where you want your final video to be saved. The other parameters come from the plugin and can be tuned depending on the results you want. After setting the paths and parameters, simply run the command and the model will load and begin generating your video. And that completes the full workflow from motion editing in the interface to final video generation. Instead of relying on text prompts, you control the motion directly with your cuts and drags, and the model follows it with surprising accuracy. It works across multiple diffusion models, and with a strong one like one, the results get even cleaner. If you want more breakdowns or advanced motion tricks, let me know.